Hello everyone, welcome back to our channel. And in our lecture third, we mastered loops, how to repeat code seamlessly. But as your programs grow larger, writing the same logic over and over again makes your code messy, hard to read, and difficult to debug. That brings us to our third lecture of Python programming series, which is Functions and Recursion. Today we are going to learn how to break down huge blocks of code into small, reusable package, which is known as functions. We will cover the function calls, type, conversions, math functions, parameters, arguments, and the mind-bending concept of recursion. Not just that, we will also solve four important problems, checking for perfect number, Armstrong number, and finding factorial using both loops and as well as recursion. This is going to be a very good session. So grab your laptop and let's begin. So my main question that come in your mind is that what is function? Before writing our own functions, let's understand what they are. A function is a simply block of organized, reusable code used to perform a single related action. Python actually gives us many built-in functions that you have already been using. For example, get print function, input function, and type conversion functions like int, float, or string. Python also has a dedicated math module full of built-in math functions. Let's see a quick example. For example, firstly, I have to import the math module, like import math. And for example, in variable a is equals to math dot sqrt of 64. Okay. And print a. And in our variable b, our absolute value, that abs of minus 10. And print our value b. Yeah. So let's run this. Yeah. See, you don't write the logic to calculate the square root, but that it automatically gives us that the square root of 64 is 8. So it gives us, and its absolute value of minus 10 is 10. So it's give me. So Python math.sqrt did it for you. That is the power of the functions. I hope you understand. And let's move to our another topic, which is creating user-defined functions. So now let's create our own function. To define a function in Python, we use the def keyword. I'm making new file. Function first dot py. Yeah. So we use def keyword and we name our function. For example, I have to greet a user. Yeah. So followed by the function name and parenthesis and inside our past value. Let's look at the concept of parameters and arguments. So parameters are the placeholders defined inside the function header, and arguments are the actual values you pass into the function when you call it. Let's look at the syntax. The user name and printing hello and username. Yeah, and here we will do our function call create user For example, Amit, and see, it prints hello Amit. And if I want to greet user name, see, so this defines that our function is reusable block of code. Function can also send data back to the main program using the return statement. Let's write a function that adds two number. We will write here. So def and our function name add number num1 comma num2, which we are passing, and result is equals to num1 plus num2, and return result. Okay. So I am calling my function add number. Let's suppose we want addition of 15 and 25 and printing our value. The sum is sum. Let's run our code. Yeah, see, it prints the sum is 40. When Python hits returns, it exits the function immediately and passes the value back to wherever the function was called. So let's move to our another examples, another problems like perfect number and Armstrong number. So the first we will do a perfect number problem. A perfect number is a positive integer equals to the sum of its proper positive divisors excluding itself. For example, 6 is a perfect number because its divisors are 1, 2, and 3. So you can see that 1 plus 2 plus 3 is equals to 6. Let's write a function for that. We are making a new file which we named as a perfect num. Yeah, let's begin. Firstly, depth, and I think our function name is perfect passing value n, and our divisor sum is equals to 0, and for I in range 1 comma n, and if our n modulo I is equals to 0, then we are gonna adding it divisor sum plus is equals to I, and after the we are returning divisor sum equals to n, a boolean value, and num is equal to taking input from the user in input, enter a number, and if perfect, if is oh sorry, I am calling my function, and if is perfect, num. Then I will be printing statement that yes, it is perfect number. And else, sorry, else, no, it is not the perfect number. Okay, so see here. See, I call my function is perfect, and my is perfect function, if it returns the value true, then my this block hits and it prints yes, it is a perfect number. And if it returns false, then this block won't hit, so else statement executes and it prints no, it is not the perfect number. So let's run it. For example, I write 6. See, yes, it is a perfect number. And now I am trying with 7. Yeah, see. No, it is not the perfect number. So now let's move to another problem, which is Armstrong number. You know, an Armstrong number like 153 is a number equal to sum of its own digit raised to the power of the numbers of the digit. Like, for example, 153 number, then do 1 cube, 1, then 5 cube, 125, then 3 cube, 27. And if we sum all these values, it is equals to 153. So our 153 is an Armstrong number. So let's make a new file and make a function like Armstrong number, Armstrong.py, and making a function is um, Armstrong. Yeah, taking L and mm, yeah, equals to string L and number digits, length of it, and my total sum is equals to sum of int of digit and to the power num digit for digits in numstr. I am return total sum is equals to n. It will return true or false, and int digit. It is digit, yes, and num2 is equals to taking the input and a number to check if it is strong. Yes, and if is strong, num two. If it is true, then my num2 is an strong number. Yeah, else print num2 is not the strong number. Yeah. Now let's code 153. Yeah, see, 153 is an Armstrong number. Now I'm entering 157. Yes, 157 is not the Armstrong number. So look how clean our main code looks because all the math logic is neatly tucked inside our functions. So now we'll move to understand the recursions. Now let's step into an advanced topic from our recursions. First, first question in your mind is that what is recursion? Simple put, recursion is a process where a function calls itself directly or indirectly. Think of it like a set of Russian nesting dolls. To open the big doll, you must open the smaller doll inside it until you reach the smallest doll that cannot be opened. In programming, that smallest doll is called the base case. Without a base case, your recursive function will keep calling itself forever, resulting in a stack overflow error. We will see that what is stack overflow error. To understand this perfectly, let's solve our program, which we will do our iterative factorial. Let's do it. Uh, Factorial. We are writing a function factorial iterative n. So firstly, we are finding the factorial using loops. And I am already make the function which name factorial iterative. Now I am starting. That result is equals to 1. And for I in range 1 to n plus 1. And result is equals to I. And return result. And now print iterative factorial of, for example, I want factorial of 5, then 5 is, and calling my function. So in case you don't want that you want that I have to print the factorial of a user input value, then it is very easy. Create a variable which is taking the input from the user, and just instead of writing 5, write the variable name. And now see the output. Yeah, iterative factorial of 5 is 120. So now I am solving this same question using recursions. Now 5 factorial is equals to 5 is equals to 4 factorial. 4 factorial is equals to 4 into 3 factorial. 3 factorial is equals to 3 into 2 factorial. And 2 factorial is equals to 1 into 0 factorial. So here our base case is when n is equals to 0 or 1, we will return one value. So I am writing my recursive code that using recursion dot py. Yeah. So I'm defining my function factorial recursive if n is equals to 1 or n is equals to 0, it will return 1. So this statement is our base case statement. Else return n into, I'm calling my function and I am calling it by n minus 1. So this is our recursive call and I am printing my statement here. Recursive factorial of I want of 5. Again, you can initialize a variable and take input from the user. And I am calling my function with 5. No, let's yeah, see. Recursive factorial of 5 is 120. When factorial recursive 5 is called, it pause and wait for the factorial recursive 4, which waits for the factorial recursive 3 all the way down to 1. Then it unwinds and multiplies everything back up. It is an incredibly powerful way to solve complex structural problems. And now, a quick revision session. Wow. We covered a lot of deep ground today. Let's pause for a quick 2-minute summary to lock these concepts into your brain. Functions are block of code designed to do a specific job and can be reused as many times as you want. Parameters are variables listed inside the function definition, while arguments are the real values you pass when calling it. The return statement exits a function and hands a value back to the main program execution flow. And recursion is when a function calls itself. Always remember, a recursive function must have a clear base state. It is a very important thing. Otherwise, it will loop endlessly. So, today's bonus question. As always, I'm not letting you to go without a quick brain workout. Here is the today bonus challenge to test your implementation skill. So, write a user-defined function called function name like find max from the three variables like a, b, and c that takes three numbers as arguments and returns the largest of them without using Python built-in max function. So, if you solve, then come back to my video and I will solve for you. And making a bonus question. Bonus question not C. Making my function find max a comma b comma c, taking three variables. And if a is greater than equal to b and a is greater than equal to c, then of course my a is greater among all. And else if my b is greater than equals to a and my b is greater than equals to c, then return b. Otherwise, my biggest number is c. So here we test our function by largest is equals to find max between 45 comma 89 comma 23. Now printing the statement. The largest number is, la- yeah. Now let's test our function. Yeah, see, the largest number is 89. If I do it like this, then yeah, see, the largest number is 120. So that concludes in our lecture 4, and you now officially understand how professional developers structure their code cleanly using functions and how to take recursive problems. So in our next video, we are explore core data structures, which are strings, lists, and we will learn about slicing, indexing, and how to implement a stat data structure using list. And if you found this lecture amazing, don't forget to hit the like and subscribe to my channel and share this playlist with your college batchmates. Until next time, keep coding, keep practicing, and I will see you in the next lecture.